Hey guys, Mr. Gattle here. Today I want to talk to you about the scientific method. So what is the scientific method? Well, the scientific method is just a way that we can process the world and understand natural phenomena. And so it's just an organized system. And so I want you to imagine, I'll draw a little guy here. Let's see, I'll give him some goggles to make him a little bit nerdy. And so maybe this guy is thinking about how do rainbows work? So he can use the scientific method to figure that out. Or maybe he's daydreaming and he's thinking about a plant and he's wondering, how does music affect this plant? Well, he can use a scientific method to figure that out. Before we talk about that, though, we need to talk about the history of the scientific method. And so it starts back here with this guy. His name is Aristotle. And so Aristotle is the guy, actually this guy right here is his teacher. His name's Plato. And this guy over here is Aristotle. And so what's really interesting about this picture is that Plato, his teacher, is really, if you notice, his hands pointing up. And so he's really more interested in the philosophical, metaphysical world. Oh, I can see that my picture's not here anymore. And on the other hand, his student, Aristotle, is much more concerned with the natural world. So philosophical and natural. And so how did Aristotle answer the questions that he had about the world? Well, he used his intuition, and he had a very, very good brain. He was a very smart person. In fact, so smart that lots of people didn't really question the things that he said. I mean, lots of the things that he said were true, but an example of something that he said that if you drop a large object at the same time as you drop a small object, the large object will fall faster than the small object. And we know that's not true. We know that that's not true. So we move on, and we move on to this guy. His name is, his name is Abu Ali alHassan, and he is really credited as the first person to come up with a method called the scientific method for answering questions. And so he said this. He said, "Truth is sought for its own sake. Those who are engaged upon the quest of anything for its own sake are not interested in other things. Finding the truth is difficult and the road is rough." And so he's actually credited with coming up with the words hypothesis and theory, and the process, the scientific process. But he actually wasn't really a scientist. And so we move on to this guy. His name is Galileo Galilei. And he lived in Italy. And he really wanted, unlike Aristotle, he really wanted to understand the truth and whether he was right or wrong. And so he used a scientific method to test his ideas. And one of the things that he tested was Aristotle's idea of two objects falling. And so again, if you think back to that, you have two objects falling, a big object and a small object at the same time. Aristotle said that the big object would fall faster, but actually Galileo Galilei proved that wrong. And the way that he did that, it's really hard to observe two things falling with your own eyes unless you have special instruments that they didn't have. It's really hard to do that with your own eyes. So he came up with an idea, and he used an inclined plane. And what he did was he put a ball on the top of it, and taking very precise measurements, he recorded those measurements and determined that gravity takes these, or well, he didn't know it was gravity, but gravity, the force that acts on these two objects was acting in the exact same way on the big object as the little object. And so there we know now that it's gravity and that it pulls at the same rate for all objects. So yeah, so he used a scientific method to figure that out. And so we're going to jump forward here all the way up to these guys, the Mythbusters. And the reason I want to bring the Mythbusters in is these are modern day people using the scientific method to answer questions. Now maybe they're not necessarily scientists, but they do use the scientific method they start with a question and then they hypothesize about something and they really test until the answer is found. And so they're an example of people who use it right now. And so thinking about the scientific method, all these people use the scientific method. We have Marie Curie and Neil deGrasse Tyson and Rosalind Franklin over here. And they all use the scientific method to find answers to science. So the scientific method starts with a question. And that's really important. So if we think back to our question, we had a plant and we were wondering, how does music affect the plant's growth? And so that's a question, right? And the hypothesis then is our attempt at answering that question. So maybe we think country music affects. So maybe we're asking what type of music affects plant growth the most. And so maybe we think country music affects that plant growth the most. And so that's the hypothesis. And I know we often hear that the hypothesis is an educated guess. It's a little bit more than that. That's kind of a misnomer in science. It's really, the hypothesis is really, we know what's going to happen. We just need to prove it. And that doesn't mean that it's always right, but it means that we have a pretty good idea of what's going to happen. And so we're just trying to prove ourselves wrong, really. And so every scientific question, when put into action, has two variables: independent variables and dependent variables. And so those are both found in the question itself. So if you listen to the question, how does music affect the growth of a plant? We have two variables. We have music, and we have its effect on the growth of the plant. So the way that I like to think about this is independent variable is the thing that I get to control. It's the one thing that I get to control or manipulate. And then the dependent variable is what results from your control of that independent variable. So in this case, in the plant case, we get to control the type of music that we're playing. We don't get to control the result, which is the growth of the plant. So in all experiments, we also need to think about all the other variables and control those. And so what do I mean by controlled variables? Well, these are all the things that we need to keep the same. So for example, we're really trying to isolate music. So for example, we would want to keep the soil the same, the nutrients the same, the amount of sunlight it got the same. We would want to keep everything else, the room air quality, the same. Okay, so that we would really isolate our independent variable, which would be the type of music, because that's really what we're looking for. So let's go on. And I really like this picture because if you look over here, you see Einstein, and if you look behind him, you can see this guy who's smoking the pipe. His name is Edwin Hubble, and the Hubble telescope is named after him. Anyway, he's really famous for coming up with for measuring redshift in the universe, which indicates that the universe is expanding. And that was an idea that Einstein actually denied at first, and later in life said that was one of the things that he regretted the most. So anyway, in every experiment, you need to have a control group. And so let's think about our experiment, and we have our plant here, and it's being exposed to music, right? Well, the control group would be a group that is in another room that doesn't have any music. And so what this does, and I know it seems counterintuitive, but what this does is it creates a system where we can really isolate the music, and we can tell if that is what is affecting plant growth or not. So everything is kept the same except for that music. And so this would be the control group over here, the one that did not have the music. And so we collect data from this, right? And data is generally organized in a data table, but then always put into a graph. And so in a graph, on the bottom we have our independent variable, and then on the side we have our dependent variable. And so in our example of the plant growth, we might put the types of music on the bottom, and then the plant growth would be over here on the side. And so we could make a bar graph for that sort of thing. Or maybe we want to measure the volume of music and how that affects plant growth. Okay, and maybe it would look like something like that. It's getting a little messy here, but all right. And so then we would use all this data and all these graphs to make a conclusion. And basically a conclusion is just, did we answer the question? Was our hypothesis right? And when we have a conclusion, then we present it and we publish those results in a respected science journal. So for example, when Watson and Crick discovered the structure of DNA, they published it in the journal Nature. And what that does is it gives all the other scientists in the world access to your methods and to your results. And when they have those methods and results, they can retest. And they should, if you did it right, when they retest, they should get the same results. But that's the thing about science. It's really uncertain. So if they retest and get different results, then they can question your ideas and come up with their own ideas. And so by doing this, we ultimately end up with something close to the truth. I hope this was helpful.